Hi, welcome to another TechByte session. In this session, we will cover 5G security and talk about the threats and scenarios that we need to take into consideration. When many folks think about 5G security, the first thing that comes to mind is the proliferation of endpoints and devices along with the gigabit speeds. However, it is important to note that in most developed countries, we already have gigabit speeds available on fixed networks, as well as a growing list of devices such as smart TVs, refrigerators, air conditioning units, cameras, and speakers that all have the ability, when faulty or compromised, to volumetrically attack infrastructure and other endpoints. The key issue is to think about what needs the protecting, and generally, this starts in a carrier network with their own infrastructure. This will mean common services such as DNS, SIP for voice-based traffic, as well as HTTPS for any customer portals used for billing and metric collection. With all this in mind, let us cover some aspects that do not just look at the number of devices and their throughput when thinking about 5G security. The first of these is the security architecture of a 5G deployment, along with any components that are specific to security. There are many similarities between an LTE 4G and 5G architecture in terms of network nodes or functions involved in security features. These can be grouped into network access security mechanisms, which provide endpoints secure access to services through the device, and network domain security mechanisms that include features for functions and components to securely exchange signaling and user data. Enhancements in 5G from previous iterations include the use of state-of-the-art security protocols, such as TLS 1.3 and OAuth 2.0 for protection and higher protocol layers, a new authentication framework to support different types of credentials, such as certificates, pre-shared keys, and username passwords. Also, a new component has been added to 5G for interconnect security, called a Security Edge Protection Proxy, or an SEPP. This key piece of infrastructure is expected to carry all signaling-based traffic between network operators and will include authentication as well as application layer security to protect sensitive user data attributes. Next, we'll move to an aspect of security which gets less exposure, but is as important, if not more important. And it is the security, traffic management, and visibility between 5G core components. If we look at previous generations of 4G LTE networks, applications were built in traditional data center deployment types on physical servers connected to switches, firewall, and load balanced, no different to enterprise IT deployments. This meant that traditional enterprise controls like access lists, rate limiting, and server protection were used against malicious intent, denial of service, and signaling flood protection against the carrier network's control plane elements. With 5G being a service-based architecture, all functions will leverage a container-based environment and likely use Kubernetes as a lifecycle management tool for the applications. This means that service providers will need to look once again to how modern applications are being deployed in the enterprise. Utilizing a service mesh to control, limit, and provide visibility into 5G core component to 5G core component will become essential. Signaling and flood protection will also move to inspecting the traffic in between containers. The paradigm shift in 5G is to migrate security and availability concerns against the infrastructure into a container-native environment. Lastly, let us look at one of the emerging use cases for 5G, which is multi-access edge computing, or MEC for short. MEC is likely to accelerate with 5G, which can use fixed networks for traffic, but is likely deployed in remote locations where a radio network is more likely. MEC is best thought of as traditional co-located data center services, but provided on a container-based or SaaS-based platform, where the physical server is a micro device deployed in remote locations, utilizing the network infrastructure to provide services to end users. A good analogy is to think of your on-prem or public cloud ingress being delivered in hundreds to thousands of locations around a country or region. Being able to deploy security policies consistently across your infrastructure, along with a zero trust approach, will become imperative. 5G is a big topic, and we've covered some of those today. Please visit us at f5.com